All right, so this module is carrying over from our last one on tuples, and we're going to be looking at the list data structure, which in some ways is a little bit more useful than tuples in Python because we can do a few more things with it. And the first big difference here is that lists are going to um, diverge a little bit from tuples in that they're changeable. So the word immutable, I used the word immutable in the last module, and it just means unable to be changed, mutate. You cannot mutate a tuple. What exactly does that mean? So if I create a tuple with three elements, 1, 2, and 3, I cannot actually change or overwrite element 1. Once that tuple has been created, 1, 2, 3, I can't go in and change the second element. And you might wonder, well, why is that? That's kind of strange. It's a strange limitation. There are some good reasons to deal with data structures that cannot change, and they're kind of beyond the scope of this course, but uh, specifically thread safety is one that makes things a little bit easier to work in multi-threaded environments, and again that's really out of the scope of this course. And there's also some implications in terms of memory usage, but the fact that it's immutable, this is the big outcome, right? You cannot go in and change one of the elements, and in many use cases this might be okay, and that's fine. um, but in some use cases, you are going to want to actually change the elements within a sequence. And when we have something like that, we're going to use instead a list. So a tuple, it's kind of an awkward name, and I think one of the reasons why we have an awkward name for it is that we have to differentiate it from a list that's mutable, and so we have tuple. So lists can be created very much like tuples, but instead of the parentheses for their literal representation, we use the bracket operators or the bracket symbols, which is a lot more like the literal value of a range, and it's a little bit more conventional. So we can create a brand new list with three elements, much like we would do with a tuple. However, now if we want to go through and we want to set element 1, which should be right here, to 5, we can use this bracket notation to assign a value to an individual element. And so if I was to go print list 1, I would certainly get 1, 5, and 3, and I would have no errors in that code. Lists, unlike tuples, can also be appended. We can add and we can remove things from lists. So again, a lot more flexibility. By the way, a lot more overhead also. So in terms of overhead and efficiency, if you can get away with tuples, if you know you can create a tuple and it's never going to change, that'll have less overhead. It'll allow your program to operate a little faster. But again, in many cases, we want to be able to change the contents. So if we want to add to a list, we can create our first list with 1, 2, 3 in it. And if we want to add to it, we can call append. All right, and so if you see on the right hand side, I've got my list in memory. If I call append 4, the 4 is going to be added to the end of this list. And if I were to print that, of course, it would print out all 4 elements. And there's actually quite a number of different functions associated with a list. And notice the syntax here. It's not something we've seen a whole lot of. The function call is actually to the right-hand side of a dot operator on the list. So this is kind of a common syntax that you're going to start to see a whole lot of, especially when we start covering classes. So lots of times when we have non-scalar data structures, things like lists, dictionaries, as we'll see, and then objects later on, we can call methods, we can call functions directly on them by using that dot operator. A bit more about the way lists work, and we touched upon this when we started talking about variables to some degree, but it probably wasn't quite as important as it is starting to become now as we're using more complicated data structures. So let's kind of keep our eye on what's going on over the right hand side here. So I have my first list and I create a list of 3 elements. There it is. And then I say list2 equals list1. And what's important to note here is that when I say list2 equals list1, what I'm saying is that list2 is going to be bound to or associated with the same thing that list 1 is associated with. List 1 is associated with a particular object, 1, 2, 3, a list. When I say list 2 is associated with the same thing, notice that I don't create a copy, right? It's the same object still in memory. It's just that now I've bound 2 different names to the same exact object. And so that might be a little counterintuitive, but it's not creating a copy. When list2.append4 is called, so I'm calling it on list 2, list 1 is going to see that change too. All right, list 1 is still bound to that very same list. All right, and so when I go print out list 1, I get a modified list, which can be a little confusing, especially if this line of code maybe is separated from this line of code by a lot of other code, right? So it might not be as obvious to us that these things were pointing to the same thing. Again, I use the word pointing and not to kind of muddy the water, but if you've done any other languages, including that use pointers and references, that's basically what Python is doing here as well. So the functions that we call, something like append, they have side effects. The side effects, so notice that append didn't return a new list. Append actually modified the list that it was called on. Those side effects, it's really important because any name, any variable name that is bound to the list object in which you call append will see those changes reflected. So you have to be very, very careful when you're assigning variable names and you're moving lists around, you're kind of assigning lots of names to the same list, that when you mutate that list, the next time you reference that list with any other names, you're going to see those changes. That's a source of a lot of potential errors. So we mentioned the append function on a list, and there's actually quite a bit more. Some of them actually have side effects, mutate the list, some of them don't. So for instance, the count function. If I want to know the length of a list, I can just type in something like ln L, right? But if I want to actually count how many elements matching a particular value, so let's say I have a list with 1, 2, 4, 2, 3 in it, I can count how many times the number 2 appears by saying L2 count 2 or L count 2. So that'll return to me how many times a particular element is found in the list. It doesn't change the list in any way. Insert allows me to specify that an element, some object, and lists are just like tuples in that any index inside that list or any element inside that list can be of any data type. And I can take that element, I can add it to any location, any index inside that list. The extend function takes a second list and adds all the elements in list 1 to the end of L. All right, so it's kind of like the concatenation of a list. Continuing, we've got the ability to remove a particular element. So L.remove E will actually search through a list called L for an element E. So if again we've got a list of let's say 1, 2, 3, 4, and we call that list.remove 3, for instance, it'll go through and it'll find and delete any instance of 3 from that list. The index function will return the index where E is found. The pop function will remove and return the value at index I. Right? So if you want to remove the 5th element from L, you just call L.pop 5, and it'll remove and return at the same time that particular value. And all of these functions, they have specific behaviors. So, what happens when you try to pop something from a list at an index that doesn't exist, right? You have a list of size 3 and you try to pop element 10. Well, it's going to throw an exception. And so the documentation for the list is something that you're going to have to find, you're going to have to actually take a look at and become a little familiar with, because there's a lot of additional functionality to all of these programs. There's a lot of different ways to use them. Lists can be sorted very easily. We're going to later on in this course actually look at some sorting algorithms and develop them ourselves, but the list can be sorted just by calling sort, and that physically changes the contents of the list such that it's sorted in ascending order. And there's some variations on how you can call that to make it search in descending order and something else. Reverse will take the existing list and transform it so it's in the reverse order. And this is in no way this is no way a complete list of all of the functions and all the methods that are available to us with the list. It's a very, very versatile data structure. And again, whenever you're working with a list, it's a good idea to have, handy some documentation about all the different functions that are at your disposal. You know how to call functions. You use them all in the same way. It's just a matter of reading the documentation. Um, we saw when you take list 2 and make it equal to list 1. So if I was to write something like this, we saw previously that that doesn't really create a copy, right? So list 2 is now simply just bound to the same thing that list 1 is bound to. And if I add to list 1, it'll see this is the difference in L2 in list 2. If we do want to actually create a copy of a list, so we want list 2 to be a new list, a brand new list, but with the same things as list 1 is. We call that a clone. So it's a copy. Two ways to do that. One is by calling the list function with the actual list that you want to copy as a parameter. That'll return a brand new, completely separate list and bind it to list 2. So if you change list 1 later on, that change won't be mimicked in list 2. Or you can use the slicing syntax where the start and the end are not provided. So basically you're saying, give me a slice of list 1 starting at 0 and going up to and including the end. Finally, there is another really interesting and really powerful and somewhat unique syntax called list comprehension in Python that allows us to write some really succinct code dealing with list objects. So let's assume that I had a list with 1, 2, 3, and 4 in it. And I've got and I want to create a brand new list 2. So it's a copy of all of those values squared. So the traditional way, or kind of the most obvious way to do that, would be to create an empty list 2, that's going to hold our squares, iterate through list 1, and for every single value x in list 1, and by the way, notice the syntax here, same thing as a tuple, same thing as a range or a string, right? For loops can iterate through elements in any sequence. A list is just a sequence, right? So for x in list 1 is giving you every element x in list 1, just like if this was a string, a tuple, or a range. And so I'm taking that x value and I'm squaring it and appending it and putting it in list 2. Right, so that's a pretty common operation. And in Python, we call that a list comprehension. It's taking one list and sort of just transforming it into another list. We have a succinct syntax available for this. It's a little complicated at first, but once you get used to it, it's actually really nice and it's a really easy way to write things. So this list comprehension syntax accomplishes the exact same thing as the previous slide. And the way to read this is to start with the for loop. All right, this is essentially a big for loop. It says, okay, for every single x in list 1, take x squared. All right, and so that's iterating. This comprehension is literally iterating through list 1, and for every x in list 1, it's computing x squared and it's putting that into list 2. And so at the end of the day, this will be 1, 4, 9, and 16. So the list comprehension actually has a little bit of an extra syntax to it because we can also choose which values to transform. All right, so it's not necessary for the original list size, all of the elements in the original list to make their way into the new list. So here I'm changing it up a little bit. I'm saying list 2 will be the square of only the odd numbers in this list. All right, and so this is kind of the full syntax for a list comprehension. And again, I like to start with the for part. For every x in list 1. All right, if we can almost think about how we could write this in a regular for loop. I'm actually going to bring up Sublime Text, and I'll write the corresponding generalized for loop. So for x in list 1. All right, so there's my for loop. That's my assignment. This is defining the source list, and it's defining the variable name that I'm going to give to each individual element. Next, we can look at this if statement. This if statement is essentially selecting which values from list 1, which x's, I want to include in this transformation. So again, if I go back to this would be analogous to having now an if statement. And then finally, for every x that survives sort of that if test, I want to take the square of it. And that's kind of like this. So if we were to look at this for loop with an if clause to see whether or not the x would make it into my second list, and then the actual application or the appending of some transformed value, this is just a much more succinct way of writing the same thing. Right? And so that's a useful tool. You don't want to go too crazy with it. You shouldn't write list comprehensions that are, 14 lines long or something like that. It's sort of, it can be a little bit difficult to read for very complex logic. But if you have some simple transformations, something like this is a great way to do it in one line and make it very, very easy and very, very, very easy to read. So lists build on the idea of tuples in that we can change them. And so with a list, there's a whole lot more functionality associated with them. We can sort them, we can reverse them, we can pop things out, we can append them. But they really are building on the idea of a tuple. And tuples essentially are building on the idea of ranges and strings. They're just sequences. Tuples added the idea that each individual element could be of a different type. But it's important to recognize that in Python, all sequences, so again, the ranges, strings, tuples, and lists, they have a lot of common features to them. So once you learn how to use one of them, you sort of already know a lot about the others. So again, if I want to get the ith element, or the element at a particular index I inside a string, a tuple, a list, I can just do sequence subscript I. That'll always return to me that element. I know that only a list allows me to do something like that, right? That's lists are mutable, tuples are not. The length function, whatever the sequence is, whether it's a string, a range, doesn't make a difference, will always return the length of that sequence. The plus operator, whatever the sequences are, so these have to be of the same type, all right? But if you do a concatenation, it'll always concatenate both of those sequences. We saw this with strings. We said we could do something like 3 times hello, and we know we would get, I don't want to do the equal sign there, but we know we would get hello 3 times. Right? So we would have something like this. Well, it works with any sequence, not just the string. So an integer times some sequence, we'll create a new sequence where the initial sequence is repeated n times. If we want to get a specific subsequence or a subset of a given sequence, we can use the range or the slicing syntax, right? So start and end. And again, the same thing with defaults. If we leave out start, it's assumed to be 0. If we leave out end, it's assumed to go all the way up to and including the last element. There's a few other pieces of syntax that we haven't seen that much, but occasionally they will come up. If we want to, let's say we want to do something to a list if a particular value is inside of it. So the in operator is actually really nice and it's very flexible. It'll work again with any kind of sequence. And I can say, E, let's say it's the value 2. If 2 is in sequence, then it'll return true if that element E is found within that sequence. We can also write not in, and that will return true if the value is not found in that sequence. So we never have to actually go manually search through a sequence for a particular value. We can always just use the in operator to determine true or false whether or not some element is inside the sequence. And then finally, we see that for. Right? And so the for loop, or the for keyword, essentially iterates over each element in a sequence, for E in sequence. And we saw that not only in for loops, but now also in list comprehensions, which is just a sort of a compact way of writing the same thing. It's a little out of place because this module is on lists, but the book brings it up here, and I think it's a pretty decent place to talk about strings. Strings being, probably the most common sequence you use. You use strings kind of without even thinking about it, but strings have a lot of built-in functionality to them, even more so than lists and tuples. So strings have a find method. I can go search for some substring S1 within another string, and it'll find the first occurrence of that string S1 in S and return the index where it's found. The split function, so if you ever want to, that's fantastic for going through and doing, text searching and stuff like that. The split function will allow you to take a string and split it into multiple strings based on some sort of a character that's going to separate things. So it's a delimiter. And so let me kind of go into that in a little bit more detail. So here I've got a string it's kind of lengthy, and you'll notice it's got some odd spacing. So over here, between these words, it's got a single space, but there's some with multiple spaces. If I just do words equals s.split with no parameter whatsoever, the functionality of the split function goes through and it looks for every single consecutive sequence without a space, and it returns a list including just those characters. Right? So I will, if I go to print words, that is going to print out a list. You can see that as with the brackets, and it has each individual word without any space around it. Right? It's trimmed out and got rid of all the space. If I call split with a parameter, that is the kind of the custom delimiter. I think it looks like oh, I was thinking that was a spelling mistake for a second, sorry. So I've got my sentence and I'm calling s.split with s now instead. So what this is doing is it's going through and it's splitting the string, but it's not splitting it by spaces, it's splitting it on s. It has a little bit different functionality in that notice that s never appears in any of these tokens, in any of these elements. So basically s is what's splitting this sentence apart, what's splitting that string. So I have thi, then I have a space I in between the s, then I have a whole bunch of spaces and an I and another space, or a and another space, right? And I've got the rest, right? And you can see actually this is a pretty long token here, and we've got that represented down here. So if you do include a parameter, that parameter is not going to turn out in your result set. If you include a delimiter and you have an instance where that delimiter is repeated, notice that you'll get back an empty string, right? In some of the as one of those tokens. So if I split on D, I'm going to take everything up until the first D, right? And so that's my first element here. I'm going to close out that token, and now I'm going to take everything up to including the next D, which is nothing, an empty string, and that's what I've got here. And then after the second D, I've got all this, and that's my spacing. Right, so the split function is great for being able to certainly split into words by spaces, but if you need to split, let's say you've got a data file that lots of times you'll get data files that are delineated by or delimited by commas. You'll have lots of numbers separated by commas or semicolons or something like that. You can take that whole data file, you can take that whole text and easily split it up by calling split with a comma or split with a semicolon and get a list of all the numbers represented by that file. So it's a very, very powerful feature. And text processing is really one of the strengths of Python.